Now let's try to understand like how your segmentation results are going to change when you change that threshold. So this is the original image we have, and this is like results by selecting like one of the threshold. Okay, and in this case we can see that most of the light pixels are gone, right? So which means that this threshold might be too close to the darker side. Okay, because all the bright pixels are gone and then the dark pixels are still there, but it's still more towards like the darker side. Now what you can do is you can start moving that threshold to the lighter side. Then what will happen is these dark pixels might start appearing as foreground, right? Because then these are also darker, but right now the threshold you have set, it's actually setting them as background. But this is a good result, it's not a bad result. But then if you go to the other side, if your threshold is too high, you can see like all these pixels are also counted as foreground with this. And this is like a very low threshold. Okay, so this was kind of like a good threshold, which was able to separate like these shady pixels with the actual black pixels. Now, this is a very good example of like why this kind of image banditization is useful. In your fingerprint, if you perform like a perfect banditization, then it's very easy to extract features from such an image. Okay, so again, this is, let's say, the input image. You can see like a lot of background noise here, right? But if you pass this to your image analysis or computer vision algorithm, you don't want to use these pixel values, right? You want to ignore them. So this could be like a very good pre-processing step you can perform. And again, you can set this kind of threshold. Then all of these pixels, which are kind of grayed here, right? Then they will be gone. Okay. Now this is another interesting example. And again, this is showing you how like changing the thresholds is actually going to affect the final output. Okay, so let's say we are focusing on this region here. I think there's some issue. So this green box should be somewhere here. Let me quickly fix that. So we are looking at this green boundary here. Okay, and if you try to plot like a histogram of just this region, you will get something like this. And you can see like you have two different groups here, right? So the left group is like darker pixels, which we can say that these are like the circles, the darker circles over here, right? So those pixels. And again, all the background, which is kind of grayish color, is this peak. So one interesting thing you can observe here is this is kind of a thick Gaussian, right? So it's a thick Gaussian, and the reason is, so if you remember like your Gaussian function, you have variance, right? So variance is something, if your variance is high, you will have a thick Gaussian, and variance is like how much variation you have in the values of your distribution. So in a way, if you think about that, the pixels you have in these darker circles, it means that their color intensity is actually varying a lot. I mean, they are darker, that's fine, but within that darker region, they're actually varying a lot. In contrast to if you look at this peak, if you try to fit a Gaussian to this, the standard deviation will be very small, right? Which means the variation is not high. And you can look at this background when it's kind of constant, like varying very little. Okay, so you have these two distributions here, and now it's very hard to say like where is the valley, where should you divide, right? You can divide maybe at this point, you can divide at this point, or maybe this point. So it's hard to say. Now these three are actually showing those three variations, the three markers we have over here. This one corresponds to 110. Okay, and here you can see that what's happening. So this is actually close to your darker pixels, which means that brighter pixels are definitely going to go away. You don't have to worry about that, which means that the background is pretty clear. You are pretty clear about the background. You will not make any mistakes there. but you will make some mistakes, like when you're talking about the darker regions. And that's exactly what's happening. You can see like the center of these circles is actually also considered as a background, right? Which doesn't seem right. I mean, you do have like lighter pixels here, and that's like that's not good. So if you move towards the right, then you can see that those pixels are actually now actually gone and considered as foreground. So this seems like an optimal threshold for this kind of image. And again, if you keep increasing this, now you're going towards the lighter pixels. Now what will happen is definitely you're not going to make any errors in the darker pixels. So you have covered all those perfectly fine. But now you observe that you're making mistakes in the background, and your circles are actually not, the boundaries are not clear. Okay, you have like a lot of leakages here at the boundary. So these are leaking pixels because this threshold is actually too close to the lighter distribution. So now this is interesting, and I mean, you can keep doing that and you can try to optimize your threshold. Now, if you think about this, you'll have to do this for each image separately, which is very cumbersome. I mean, you don't want to do that, right? What if you have a million of images? Then you will sit and like just try to analyze each and every image and come up with a threshold. You will get bored. And some people might still be doing that. I mean, we don't know, but that doesn't seem like a good job to do.